Okay, so we're going to find the values of n less than or equal to 7 for which n factorial plus 1 is a perfect square. So let's go ahead and take a look at the first one. So 1 factorial plus 1 is equal to 1 plus 1, which is 2, which is not a perfect square. Not a perfect square. In the future, I'm just going to put an x when it's not a perfect square. All right, so let's look at the next one, which is 2 factorial plus 1. This is equal to 2 times 1, right? Plus 1, which is equal to 3, and that's not a perfect square, right? So 3 factorial plus 1, which is equal to 3 times 2, right? 3 times 2, which is equal to 7, which again is not a perfect square. Let's look at 4 factorial plus 1. So now that's 4 times, and then this was 3 factorial, so 4 times 6 plus 1, which is 25. That is a perfect square, right? Because this is equal to 5 squared. So that is a perfect square. Let's look at 5 factorial plus 1. So that is 5 times, and this was 24, right? Plus 1. Now let's break this up. So this is 5 times 20 plus 4 plus 1, which is equal to 100 plus 20 plus 1, which is 121, and that is 11 squared. So that's also a perfect square. Okay, so let's look at 6 factorial plus 1. So that's 6 times, and then this was 120, right? 6 times 120 plus 1. So that's 6 times 100 plus 20 plus 1, which is 600 plus 120 plus 1, which is 721. Okay, so now this is interesting because I don't know if that's a perfect square or not, right? So what we're going to do is I know 20 squared is 400, right? And 30 squared is 900. So this has to live somewhere between 20 squared and 30 squared, right? So I'm going to look at 20 plus x squared. That's going to be 400 plus, and this is going to be 40x plus x squared, right? Now let's see. I have to do 400 and then so 721. So 6. So let me look at x equals 6. Let's just look at that. So that's 400 plus 40 times 6 plus 6 squared. And that's going to be 400 plus 240 plus 36. And that is 640 plus 36, which is 676. So that's not quite to the 721. So let's look at x equals 7, right? So that's 400 plus 40 times 7 plus 7 squared. That's 400 plus, so that's going to be 280 plus 49, which is 680 plus 49, which is 729. Oh, just shy. So I now know this isn't a perfect square because I know this, right? I know, what is it? X equals 6, that would be 26 squared, right? So 26 squared, because 20 plus x, that would be 26 squared, right? Is less than, because 26 squared is 676, so it's less than 721, which is less than 27 squared, right? So of course, this implies that 26 is less than the square root of 721, which is less than 27. So this means 721 is not a perfect square, right? So that's an x, right? So, and of course, 721 was what I got for 6 factorial plus 1. So I know 6 factorial plus 1 is not a perfect square, right? So let's do the last one. Let's look at 7 factorial plus 1. This is equal to 7 times, and then it was for the 6, 600 plus 120, so it would be 720, right? 7 times 720 plus 1. This is going to be 7 times 700 plus 20 plus 1. And that's equal to, so 7 times 700 is 4,900 plus 140 plus 1, which is 41. But look, this looks very similar to if I were to look at 70 plus x squared, because of course it's 70 plus something squared, right? So let's see, this is going to be 4,900 plus 140x plus x squared. And look at this. If I look at x equal to 1, that's going to be 4,900 plus 140 times 1 plus 1 squared, which is exactly this, right? 50, 41. So I know 71 squared is equal to 50, 41, right? Meaning that 7 factorial plus 1 is a perfect square. And this was a really neat problem in order to sort of showcase how we can find perfect squares.